GM guys, welcome back to another episode of The Rollup. Today we are talking with Murat from Primev about everything MEV. MEV obviously has been around a long time. It has been this black box that everyone kind of knows about but doesn't fully understand. Today, Murat, who was previously at Block Native, one of the block builders, is going to talk us through the landscape of MEV as it exists today. We're getting new innovative technology that protects users from toxic MEV like MEV Boost and now MEV Commit. Watch today's episode to learn more about MEV Commit, about pre-confirmations, and everything in the Ethereum block supply chain. Hope you guys enjoyed today's episode. Before we get into it, a word from our sponsors. Enjoy. Cartesi is your home for app-specific rollups. At the forefront of developing new tools and platforms that enhance the capabilities of blockchain technology, Cartesi enables applications that are flexible and built to scale. Build on a full Linux environment and use traditional software libraries, but in blockchain development. Go to cartesi.io, that's cartesi.io, to learn more about building your own app chain today. What is going on, guys? Welcome back to another episode of The Rollup. Today we are talking about MEV, which was something that I thought if we were looking back a while ago, I thought this died when it was miner extractable value. I was like, oh, I'm not a miner. Everything's proof of work. Ethereum's going to proof of stake. Why should I care about miner extractable value? Turns out me and I think a lot of other people missed the boat because it quickly rebranded to maximum extractable value. And is now probably more important than ever in like a really robust economic machine embedded into the fabric of Ethereum, as well as like many other blockchains. And so today we're here with our friend Murat from Primev, and we are going to be catching up on MEV, as well as pushing forward on commitments and some of the things that are happening in the block building and block production space as of recently. So very excited to jump in. Murat, welcome to the show.
Thank you. Excited to be here and dive into these topics with you.
Awesome, man. Quickly, I think this is your first time on the Rollup. We did have a previous conversation on a different channel, but for everyone who's unfamiliar, why don't you give yourself a little bit of an intro, and then we'll catch up on what MEV has looked like in recent days.
Yeah, definitely. I've been sort of a day oneer. I was on Reddit when the Bitcoin white paper dropped, so been in it for a long time. But most recently, I was product lead at Block Native when during the merge of Ethereum, we ran mainnet block builder and the only non-Flashbots relay spec at the time, and that kind of put me in a first-hand position into looking into all things MEV and the ecosystem that's surrounding it.
Awesome. Yeah, I was catching up with Matt from Block Native as well out in Brussels. Some leaders in the MEV space. And so when you guys were running a block builder, why don't we talk a little bit through that history, and we'll kind of like let that pave the way, because nowadays I think it's pretty much common knowledge. I want to demystify like any misconceptions that I think people might have about MEV, and then just kind of like unpack what the like more recent and current state of the industry is. I think it's pretty much common knowledge now that block building is quite centralized. We even have Vitalik and then the Mega ETH crowd that is saying like that's not a problem. Like it's fine that block production is centralized as long as we have decentralized block validation. That's my understanding of it. Maybe didn't quote that exactly correct, but I'm curious, like from your personal experience running a block builder at Block Native, what was that experience like? How did you see the centralization playing out? And I realize that there have been some shifts now. And so, yeah, let's first start with like what your experience was at Block Native running a block builder, and then we'll get into what you're doing now with Primev.
Yeah, I mean, it generally, it's good to kind of take this lens of like, why do we have this centralized block production regime? It's because we wanted to decentralize the validator set. Right. So how could we decentralize the validator set? How can we have 1 million proof of stake validators like we do today? And the architecture for that ended up being, okay, we'll need to outsource block production to these specialized entities to get the maximum yield, et cetera. So it's rather a trade-off that we've made, and we've said it's okay to have a little bit of centralization over here because the core of what we care about remains decentralized. So it's always good to kind of put that perspective, because people say, oh, the market seems to have evolved into centralization. No, actually, market has said that it's okay to have this bit of centralization over here in order to keep the main thing decentralized, right? So that's very important. But getting into some of the experience related stuff, it was just really exciting to have another relay that was called Dreamboat at the time, that we launched at Block Native. And we nobody knew some of these vertical integration related advantages, etc. Like, we found out that the Flashbots relay had this two block submissions per second kind of rule, and our relay did not at the time. So people were able to win more with our relay because they could submit these last second, last millisecond even blocks, etc. So it was very unclear what the MEV game was going to be in the scheme of block building, right? So a lot of people were thinking, okay, like, if I can bunch up the most order flow from the most wallets, etc., I could probably make the most valuable blocks. Well, it turned out that if you have this top of block arbitrage transaction that you yourself put in because you're a sophisticated entity, you could create the most valuable blocks. Obviously, order flow is a part of it, etc. But it just the game evolved very quickly after the merge, I would say, over the next 20 months or so. So it wasn't really clear how one would win. And as that evolved, you saw the ecosystem evolve, and folks like Titan and Beaver Build also rise up, and rsync as well. So that's kind of a brief history of how it came about, and then how Primev came about is particularly from the first MEV Boost stewards meeting that happened at DevCon Bogota in 2022. I was invited as a representative of Block Native, but we had this problem that our users were telling us, "Hey, I want guarantees that I can be in this block that you're going to be building," and we can give those guarantees about 10% of the time when we were actually winning those blocks. But all those other times, nobody else could give them either. So you would have to go to each block builder separately and get some guarantee. And how would you do that, right? So I put forward this idea of, what if there was a network that these users could deal with, and they could source these guarantees from this network rather than going to each block builder and requesting them. And that's how the early ideas of what's today MEV Commit came about, and that's how Primev was found.
Awesome. Okay, so I think we ought to get into MEV Commit. Maybe we can dive right in. And so why don't we unpack MEV Commit, but also the other tools that block builders and solvers and validators are using for the entire block supply chain.
Yeah.
Yeah.
Let's kind of go over those first. I mean, you have MEV Boost, which is kind of the largest piece of it all, which is kind of the supply chain of block builders that are building blocks, relays that are delivering the blocks to MEV Boost instances that are run by validators or proposers in the case of proposing blocks. So it's kind of this pipeline where this payloads of transaction information are going through, and they participate in this what's called a just-in-time auction. So basically, there's a real-time auction on being able to bid the most amount of value in order to win that right from the proposer to give your block to the proposer and having or have built it, right? So it's an ongoing auction. They're bidding in real time, these block builders, for value. And as a result, at some point, usually a little after now the slot, cutoff time, the proposer picks one of them and signs it, and then the payload is delivered through the relay. Now, a few kind of iterations of this MEV Boost sidecar have come to market. That people are building basically their own forks and versions of it that have different flavors. I don't think it, I want to promote any of them here because, we want to stay neutral to these sidecars. But at the end of the day, MEV Boost is the most widely used one. And there's more layers that are being built on top of it. One of those layers is MEV Commit, right? So it's this kind of commitment network for real-time commitments that you can layer on top of MEV Boost. It does not require any changes to MEV Boost, and it does not require an extra sidecar to be run by validators. So it's 100% compatible, and that's kind of part of its strengths. And we believe many other such layers for different use cases could be built similarly on top of MEV Boost, using MEV Boost essentially as a platform. Yeah, that's kind of the lay of the land in terms of the MEV pipeline today.
Awesome. Okay, so like my smooth brain here, just to simplify this down, is like basically thinking of these as auctions, right? And correct me if I'm wrong, but MEV Boost is essentially an auction between builders and proposers, right?
You could summarize it that way. I mean, MEV Boost is a piece of software. In that software, there is essentially the proposers running this auction and saying, "Hey, bid to me." Right? Hey, block builder A, B, C, EF, whatever. Send me your bids, right? And you as the proposer are running this auction because you can just pick one of those bids at any given time. You have that optionality. So it does not, come with rules as a, hey, this is when you can commit to one of these bids, right? So you're running that auction as the proposer, and yes, these bids come in and you pick one, and that becomes the block that you must, propose.
Okay. Now, like, I want to go on a little bit of a tangent, and this is like a dark forest, and so I'm just kind of like feeling out and like seeing where we can continue. I think there's another idea here where, so my understanding of the proposer network now, is that proposers don't know who's the proposer ahead of time, and so once there's a block once we're in line to produce the next block, I'm kind of like told by the network that I'm the proposer, and then I have to source these bids to figure out what block I'm going to propose. Now there's this idea of, and so I have to pick a bid before the next block is to be submitted. And I'm basically gonna pick the one that pays me. I'm gonna pick the highest bid, right?
Yeah.
And so there's this idea of multiple concurrent proposers that's being floated around right now. Like I saw the Paradigm guy, kind of like Dan Robinson said, like, oh, he supports this. And I'm just genuinely curious if you could kind of unpack what that means and kind of demystify it for our audience, because I think that's pretty timely nowadays.
Yeah, I support it too, by the way. I think it's a great thing for the decentralization of Ethereum. So the core problem here is this proposer has this monopoly on what that next block will be, right? And you could argue that this is a point of centralization too. I would certainly argue that. And the existence of this is a problem because of the centralization factor, but also because it exists, people kind of come up with all sorts of designs that piggyback off of this proposer monopoly, and that kind of further or cement the centralization vector here. So I believe going towards a vision where having multiple concurrent proposers is a better path for decentralization, and it will surface better designs on all sorts of in protocol and out of protocol approaches to all sorts of problems and solutions. But yeah, the multiple concurrent proposers is a proposal for essentially breaking down this proposer monopoly, that there would be more than one entity that proposes this end block, and none of them quite know what's happening. They only kind of have their own vision of their piece of the block. And this kind of maximizes the optionality for each of these proposers, while barring them from seeing what else is happening or being able to fully take advantage of some opportunity that is there. I don't think there are concrete proposals onto how it will come together with PBS yet, or what it would mean for block building, etc. But there are some early proposals into how it could generally work, and then I believe people will come figure out some of the details from there.
We probably should have started with PBS, because I feel like we have these layers. PBS is like pretty fundamental. MEV Boost is built on that, and now MEV Commit is built on MEV Boost, right?
It's independent, but it does work in tandem. So you can run MEV Commit without running something else, but really they work well together.
Okay, so to just kind of like paint the full picture here, PBS was something that was implemented with proof of stake, and it was essentially to say, all right, we're going to separate. PBS is proposer builder separation. We're going to separate the roles of proposers and builders, and we're gonna say that someone can build blocks over here. Everyone can compete and all of this is in the spirit of healthy competition, right? So that we can kind of like have these micro competitions with like more sophisticated actors and specialize in that particular area of competition. And then we can kind of like funnel the winner for the most efficient pipeline of blocks through the Ethereum supply chain. And so we separated out and we've unbundled proposers and builders. And now we have these block builders, like you mentioned, Titan and Beaver build, that are competing to find the most valuable block. And then they're going to submit bids to the proposer that is selected for proposing the next block. Yep. Now, MEV Boost is like the mechanism that allows them to bid, right? That allows builders to bid to the proposers and offer them some sort of incentive or tip to choose that block that they've built.
Say that, yeah.
Proposers are then like, they're going to choose the one that has the highest value for them to propose. But with multiple concurrent proposers, like how is this picture changed? Because the way I see it, like all of these block builders are competing. They're going to try to build the best block. And then they're going to submit their bids, and the best bid is going to get picked up. If there's multiple proposers, like, is there ever a case where these proposers don't just pick up the highest bid? Like, why do we need multiple proposers when it's just going to be the highest bid that gets picked up, or is that not the case?
Censorship is usually the reason. So what's happening on MEV Boost today is actually they're not picking the theoretical highest bid. They're first saying, hey, I want an OFAC compliant block or a non-OFAC compliant block. So a kind of a free-for-all type of block for, maximum censorship resistance, or one that abides by OFAC rules. Now, once you do that, then you pick the highest bid that fits under that criteria, right?
Can I interrupt you just for a question? Yeah. So, is that censorship done at the block building level or at the block proposer level?
Well, you could argue both, but really the proposer makes a declaration and saying, "Hey, I will only propose an OFAC compliant block." And once they say that, then the block builders, build a block that is compliant for
the most valuable compliant one.
Right, essentially, right? So, and this is not great, particularly. And the other thing is the block builder has optionality to just censor whatever transaction. And we're seeing some instances of this where, they're competing in this auction, but in the last few milliseconds, they'll figure out a really juicy arbitrage transaction. And they'll say, you know what, like, discard this whole block, just send this block with this one transaction in it because it's just so valuable. So then what you're kind of participating in is in some sort of censorship where you're just saying, hey, you're just not valuable enough for me right this moment. Sorry about your transaction. And the proposer is still getting like the most value out of it, but it's really not in the best interest of the protocol or the network. So it will, breaking down the proposer monopoly will, one, break avenues of the censorship, whether it's OFAC or some other reason, and then it may have other impacts on transaction inclusion that is not purely based on profit, but also, what's best for the protocol overall.
Mantle is a layer 2 blockchain with one of the biggest on-chain treasuries in all of crypto, and they had a 100-day campaign called Metamorphosis live now. What this is it is a campaign for their liquid staked ETH token, METH, as well as their upcoming liquid restaking token, CMETH, where you can utilize this token on the Mantle network in a variety of different apps, some of your favorite restaking protocols and DeFi protocols, and earn yields in the form of powder, which will eventually be turning into a governance token. Mantle's been around for a while. We like them because they use their own form of EigenDA. They have a good ecosystem and they're growing. So check out this 100-day Metamorphosis campaign and hope you guys enjoy the rest of this video. Everclear is pioneering the clearing layer. The clearing layer can almost be thought of as Splitwise when you go on a trip with friends, but for the blockchain. What I mean by that is when users are sending cross-chain messages, there's oftentimes fillers and solvers who have balances left on different chains that they need to rebalance and reset their positions. This is where Everclear comes in. Everclear is pioneering a collaborative approach to the chain abstraction future, and they are willing to work with interoperability partners, solvers, and other providers in the space to build a interoperable and chain abstraction feature. Please check out Everclear at everclear.org, and welcome back to the Rollup.
OFAC compliant transaction is a block that is OFAC compliant would be a subset of the transactions that would make up a non-OFAC compliant block, right? So is it the case that like always the non-OFAC compliant blocks are basically strictly at least as valuable or more valuable than the OFAC compliant ones because they're made up of essentially the same transactions, except some of them are non-OFAC compliant. So you can put those in there if it would make the block more valuable.
Right. If the block isn't full, then in most cases it would be more valuable, including the OFAC transaction. But if the block is full, then you have to see whether the fee about that OFAC transaction is, higher than one of the fees of the other transactions in the block. But generally, I think it would be okay to say that, these are just transactions you're leaving on the table, right? So why not include them in the case of a pure profit mindset?
Okay. And then with the case of multiple concurrent proposers, would it be the case that like both the OFAC compliant and the non-OFAC compliant block get submitted to like now this network of proposers? And then how does it work? Like who ends up being, because right now it's just the network tells you who the proposer is. They're the only ones that can submit a block for that slot. But in the multiple concurrent proposers world, is it basically whoever proposes the most valuable block is the one that gets submitted? Or who ends up being the proposer in that world?
I believe the current specs being talked about are about partial blocks being submitted by these proposers, and then I'm not sure if some algorithm or the protocol figures out how to combine them, or maybe one of them is elected as some sort of leader to do that. Again, we need more details on the specs of this. In general, and even just a spec is usually not enough. Like you really want to see, because the devil's in the details, and that's where things get figured out. But some of the smartest people are talking about this, so I'm sure it will get figured out. But yeah, the current regime, I believe, is for each of the concurrent proposers to have a partial block based on what they're looking to get on chain, and then some sort of process figures out a combination of all that to create the final block.
Got it. Okay, so the OFAC compliant proposers can submit OFAC compliant partial blocks. The non-OFAC compliant, they can submit their set of transactions, whether it's OFAC compliant or not. And then there's a smart contract that maybe figures out the right combination for the most valuable block and submits that to the network.
Yeah, I'm not sure it'll be a contract because the process is off-chain by nature. But yeah, some sort of process, and then it will be a combined block. So this would mitigate the censorship issue for those OFAC transactions, for example.
Right. Okay. Cool. And then we can combine those by some set of rules. And it's almost like there's like we have like block builders for the little subsets. Those get proposed by proposers for partial blocks. But then there's this one meta builder that sort of takes those partial blocks and combines them at the end of the day as a last step before it gets submitted to the Ethereum network.
Yeah, and I'm not sure if the latest kind of proposals are for that to be done by the network or for that kind of information to be sent by the proposers to a block builder, and that block builder kind of assembles that final block. Again, the devil's in the details here, but the theoretically this multiple concurrent proposers approach would mitigate a lot of the issues that Ethereum has today.
Okay, cool. We'll kind of pull ourselves out of that rabbit hole a little bit because I realize that there is still a lot of research to be done there. And so let's switch gears back to MEV Commit. And so I think we've spent a pretty good amount of time kind of like outlaying like what the proposer builder relationship looks like and how the market mechanisms work between those two parties. Now let's layer in MEV Commit. Who does that affect and how?
Yeah, it affects all transactors and also execution service providers, which is partially why we have two roles on this network. You can either run a bidder node to bid, and if you're a transactor, you might want to run that. And you can run a provider node if you're an execution service provider. So in the case of L1, this might be block builders. In the case of L2, this might be a sequencer, that is the provider, etc. So really, it's really that this concept of the priority fee and the base fee that is applicable in the current Ethereum pipeline is not sufficient to express everything that the transactor wants to express. And you can, Flashbots has done a great amount of work to already expand this a little bit with this each send bundle option, where you can bundle a bunch of transactions in some order. And you can specify, okay, these ones can revert and that's okay, kind of thing, and send it to block builders directly, right? What MEV Commit bids provide is basically another layer of time sensitivity on top of the transaction, that, hey, I want this to be almost immediately kind of committed to or pre-confirmed. And also that you can add these other bells and whistles, like, hey, I want this to be to get an execution guarantee, right? So you're receiving a commitment not only for having that transaction be pre-confirmed, but also that a guarantee that it will execute in that block that it's specified for. Now, these two kind of aspects are things that I might be willing to pay more for as a transactor, because it reduces my risk, right? Let's say I'm going to mint an NFT. I don't want that transaction to just go on chain. I actually want to mint the NFT. It doesn't help me if there's it goes on, but it just reverts and I don't get the NFT. Right. So I want that guarantee that it will execute. So I'm willing to pay a little bit more so that I can receive that guarantee in real time. That's where a lot of the original thesis for MEV Commit was that this time angle, we have this 12-second slot, and within that slot you can get these guarantees intra-slot, and then the execution angle that you will receive a guarantee that it will execute are aspects that people would be willing to pay more for. And we've asked a lot of people, and they were confirming it at the time. But now that we have a live testnet, we can see the actual value that this brings on to Ethereum, which helps secure the network as it trickles down the MEV Boost pipeline.
Awesome. So what are you seeing in testnet? Like, what has been kind of like the user feedback from some of the players in the pipeline? And sort of how has this, like, what are some metrics that you can give us as far as how this is going on testnet?
Yeah, I mean, we're still in its early days. The latest release went out on July 10th, so it's like right around ETHCC, where execution pre-confirmations are the default essentially. But since then, and today's the 31st for those who might be listening, since then we've seen a little over 5 ETH worth of value trickle down, extra value trickle down in these blocks. And the average MEV Boost block on mainnet is about 0.05 ETH these days. And this added about 0.005 of value per block. Again, this is on testnet, so take the results with a grain of salt. But we're seeing anywhere from 1 to 21 transactions pre-confirmed in a block currently. And there's up to 10% of extra value that people are getting from the execution layer on Holsky testnet today. Now this will mature and it will change a little bit as more people adopt the network, and then we will see how it performs in a real world environment when we take it to mainnet, and we can see things like transaction state contention and how that affects bidding behavior and other kind of gas related spikes that might affect people's sense of urgency to bid more for pre-confirmations, etc. But the fact that we're already seeing extra yield for validators that have opted into the network on its testnet is proof, at least for someone like myself who's been working on this for close to 2 years now, that there's some real value here. This is actually mostly good for the network in terms of getting more yield for validators, which is a proxy for network security, obviously.
Awesome. I got a bunch of questions here. First of all, like, when you say 5 ETH has trickled down, who does that trickle down to?
Yeah, so that's a great question. So what's happening today is, let's say I have 1 ETH, for example's sake, and I want to bid 1 ETH for my transaction to be pre-confirmed. This 1 ETH is committed to by a block builder or a set of block builders. And essentially now this block builder has 1 ETH of extra value that they can bid in the MEV Boost auction to win that block building auction, right? So this kind of works like additional order flow for them and additional value for them. So they get more bidding power in the MEV Boost auction. Now, in the good case scenario where this block builder wins this block, now what they do is generally they would include my transaction in that block and have it execute. And then the MEV Commit Oracle would check that on the layer 1 and say, okay, this block was built by, let's say, Titan. They did deliver on this commitment, therefore reward this 1 ETH to Titan. right? So Titan has basically paid the value about this pre-confirmation upfront to the validator by participating in the MEV Boost auction, and then they recoup it back once this proves that they have delivered on this commitment. So the value pretty much flows down the MEV Boost pipeline from the bidder to the provider, which is usually the block builder in the L1 case, and then down there to the proposer.
Right, because they're able to bid more in this MEV Boost auction to the proposer, and then the proposer is able to. They have more, so they're more incentivized to choose the block with this pre-confirmation. Okay, and so this proposer is basically like a single validator, right? That is kind of chosen, quote unquote, randomly by the network.
Yeah.
Okay, and so when bidder is making, first of all, let's talk about why a bidder might make a bid like a higher they might bid a certain amount for some extra security assurances. You mentioned like high gas cost. This isn't something that like a retail user is going to do, right? This is like more institutional or sophisticated user that maybe has a large example here is like maybe they have a large position on Aave, right? They want to avoid liquidation, so they're going to pay a pretty hefty sum to have their transaction of repaying some debt or adding some collateral included, and not just included, but an assurance from a block builder to commit to executing that repayment transaction or added collateral transaction high enough in the block or early enough in the sequence that they would avoid liquidation. That's kind of like why a bidder might, that's one particular use case that a bidder might submit a bid for higher assurances.
Exactly. Yeah. And end users will definitely benefit from this. They might not be interacting directly with it. They might be interacting with some sort of order flow auction where, the solvers involved there are doing this underneath, and they're just getting those guarantees, right? Similar to how the real world kind of finance work. Like when I swipe my credit card, I'm not really dealing with the complexities of bank transfers and settlement underneath. I'm just swiping my credit card and seeing a confirmation on my screen. But a whole bunch of kind of sophisticated actors are doing things underneath to deliver that.
Very cool. Okay, and so there's another element to this. Okay, so that covers kind of like top of funnel, like why a bidder might submit a higher bid, beyond just a gas fee, but something to the effect of like guaranteeing execution. And so when they submit that bid, you mentioned like maybe they submit that bid to Titan, right? And then Titan has an extra ETH to bid in the MEV Boost auction. When a bidder submits a bid, is it just going to a single block builder, or is it going to like the entire network of builders, anyone who's willing to make that commitment?
Yeah, so it would go to, by default, it would go to all providers on the MEV Commit network. Assuming that most block builders will be on there, it could go to most block builders. But MEV Commit has programmable privacy so that you can go in there and say, hey, you know what, I only want these 3 block builders to see it, or something like that. And then, your bid would be encrypted and only they would be able to see that. So you have the optionality as the bidder to, select which block builders or providers that you want them to be able to see your transactions.
I'm starting to come to the realization that there's like this phenomenon that's happening of gas and price variability. Like no one really knows what the price of block space anymore is. Like when it was, I remember maybe this was all the way back in Bitcoin. Maybe it didn't follow ETH to proof of stake, but I remember if I submitted the highest gas fee, I was supposed to get like the best inclusion or execution, right? And it's just not the case anymore. Because everyone has these different incentives going on for the gas fees that they're going to submit. But there's also another wrinkle to this where a lot of order flow is going through like private channels. If I'm understanding correctly, like I'm also aware of this tool from Flashbots. I think it's called MEV Protect, where it's supposed to protect and that's more of a retail tool for users to protect themselves from MEV. They submit their transaction in a private channel, so that other builders or other people that are watching the network, maybe searchers, aren't able to see that transaction, and they're not able to front run it, back run it, sandwich it. So how like when you're taking into account like this idea of private order flow, and we're kind of like restructuring how the gas market is working. This is a very general question, but like how are you viewing the gas market nowadays with all of the private order flow? Um, are we getting to a place where we're just getting this market more and more dislocated, or is there a way to arrive at a efficient market for gas? And MEV Commit is one of the tools that helps us do so.
Yeah, I mean, the market is getting more sophisticated, and that's generally a good thing. You want a lot of sophistication to happen so that you can extract the most efficiency out of whatever system that you have, right? Obviously, if you can have it wave a wand and have it be simple, it would be great. But as long as you abstract that from the end user or consumers, then generally you end up with efficient systems. Now, I'm not saying they're the most amazing systems, and in an ideal world, that's how they would be. But this is how the real world works. For me to get a cup of tea and from Amazon, I might have to get on a shipping container from China, go through customs and go through some sophisticated stuff and get here, right? But I don't deal with that. The gas is getting more complex, and there's things like state contention that add to it, right? So, in Bitcoin, you didn't have this because it's mostly kind of transactions to and from, different addresses. On Ethereum, you have state, and the state kind of changes based on, a whole bunch of factors. In the case of DEXs, it's about price and liquidity and all sorts of other things. That state basically determines the amount of money you might be willing to pay to claim that state. And in the case of arbitrage, where there's a price on chain and there's a price off chain, that can determine how much that state is valued at that given time. And then there's other things like censorship. So I might be willing to pay more not to get censored or whatever it is. So there's just a new angles to gas as the system kind of matures. And I don't think that's going to go away. I think we're going to get even more angles. And what MEV Commit introduces is this time angle and this execution angle, right? Hey, I don't want to wait 12 seconds to hear back from the result of my transaction. I want to hear about it right now. And in the case of a bridge experience, for example, I might have to wait a long time to bridge my coins from Ethereum to, let's say, Optimism, and I don't want to wait that. So I can have some sophisticated entity like a solver take on that risk, use something like a pre-confirmation, and take on the rest of the reorg risk, and then give me my coins instantly on Optimism, right? So my experience will be that I'm paying slightly extra maybe, but maybe that's even hidden from me, similar to credit card fees, right? And I just click a button, I instantly have my coins on my destination chain. Underneath, if solvers work, they get pre-confirmations, they absorb reorg risk, etc.
Yep. Okay. And so the way that I'm thinking about MEV Commit is essentially like a market for pre-confirmations, which is maybe one way to think about it. And these actors that want to maybe protect themselves from liquidation or get an NFT mint or all of these reasons and use cases for why I might want a pre-confirmation, I'm able to pay a block builder some extra gas for the pre-confirmation and the assurance that they're going to execute my transaction.
It is that, but really the pre-confirmation is really like the most basic commitment that you can get. And the word pre-confirmation really conveys, the time nature about it, but not these other natures about like execution, it being at a precise block, it being at the same time as another transaction that is elsewhere, for example. And that's how the network MEV Commit kind of matures into these commitment games, right? So you have these synchronous commitments where I might be a solver who's doing an arbitrage in two different DEXs and two different chains. And I want a commitment from the sequencer of this chain over here and the L1 block builders over here synchronously, so that I can de-risk my transaction as much as possible and provide some experience that I want. Same thing on the instant bridge case we just covered, right? So the commitment there serves for much more than a time-based pre-confirmation. and you get execution guarantees, right? So, one of the big problems on networks like Solana is that even though the network is really fast, a lot of the times their transactions will fail. So, it's great that my transaction is fast, but, I just fail faster now instead of getting some success. So if I could receive a commitment from the Solana validator of some sort that, this transaction would execute, that would provide a much better experience than just kind of failing fast, right? And it can have even more robust guarantees that it will execute at the same time as my ETH transaction over here, at the same time as, maybe multiple chains that I'm working on. Then I can really make, my experience as efficient as possible and de-risk any execution related costs that I might have.
Yeah, the idea of cross rollup or even cross L1 transactions, I think that is a use case that is particularly fascinating and has not quite been unlocked yet. And so it's really cool to think about how we could operate cross rollup domains by market functions at the L1 level, because these ultimately settle to the L1. And we just receive the assurances from the L1, and then we're able to arrive at some guarantees about execution at the L2s. And I mean, we were in Brussels. Vitalik, I heard, have a couple presentations about pre-confirmations. And then Justin Drake was also kind of involving this in like a based rollup based sequencing level. And so what I gathered from Vitalik's sentiment out there was basically like, pre-confirmations are good. Basically, people like pre-confirmations because, to get full finality is going to be slow and it's going to be secure. And so, if we can provide some like assurance, some medium strength assurance that happens much, much faster, people are going to like that, so that they don't have to wait to the full L1. And so I think there is a strong appetite, and I think Vitalik was voicing this as well, is there's a strong appetite for pre-confirmations, both at the roll-up level. And I think that's kind of like why people use roll-ups, is like, because it kind of provides them some assurance that their transaction will get executed. And it happens much, much faster and much, much cheaper than waiting for full finality.
Yeah.
I'm curious, like, from your perspective, the other thing that I hear Vitalik and Justin Drake and like the Ethereum Foundation pushing a lot is everything based, right? Like, because I think there's like
Vitalik is pushing that. I think Justin's pushing that, but yeah,
the based rollups.
Yeah, I mean, it's been this vision that Justin proposed that's been interesting, but there's a lot of contention within the EF about whether they're going to be a thing or that they're good. I think Vitalik's definitely starting to absorb some aspects of it based on my impression of his talks at ETHCC. But there's still things that are yet to kind of manifest there. But I mean, there's very exciting developments. We're part of some of the developments, at least with Tyco and some other based rollup, based rollup as a service kind of SDKs, like Spire, etc. The full vision needs to prove itself still by going on mainnet and delivering the end experience that it wants to. It's still able to do some stuff today, but it's not fully there with pre-confirmations and all of these things that it needs to provide to really deliver that based rollup experience.
Covalent is solving the long-term data availability problem, where a lot of the data availability providers today in the modular space, when you post data to them, they actually only hold that data for about 12 to 16 days. And then it's basically, it can go into an archive node, or oftentimes it's just kind of put away into the abyss. And what Covalent's trying to do is build this long-term data availability solution, which can plug into some of these modular data availability providers and provide this longer-term perpetual data solution. So what we try to think of this as is when you post transaction data onto Celestio or Veil or any of these modular DA solutions, or even Ethereum, Covalent is able to provide a long-term data storage and data availability platform for that data after the time period. Blockchains are billboards, not databases, and we need these providers in the space to be able to kind of hold on to the long-term data that is provided from these providers and these blockchain state. This is where Covalent comes in. They just had a nice rebrand. Check them out on Twitter as well as the website. Thank you for being here. Hope you enjoy the rest of the show.
And so what is kind of the relationship or engagement that you guys have with Tyco? How are you guys working with one another? Because I'm curious, like I've heard mixed things about base rollups, and even just on this podcast, I feel like there's still some confusion about base rollups that's out there. So like, how are you helping Tyco achieve this vision? And then
we don't have an official relationship. I mean, we know the people there, but we've just kind of created an open source repo, tyco.preconf.eth. And on that repo, we've started kind of playing around with the idea of Tyco being able to use MEV Commit for L1 pre-confirmations. And this will soon mature into a full-fledged end-to-end experience that can be provided on Tyco. And with us, there's other kind of efforts around the ecosystem to have Tyco have an end-to-end pre-confirmation experience. Nethermind has been working on this as well. I believe they have a closer relationship maybe with Tyco. I think they may have received a grant about it. But there's other efforts that are happening to make this based rollup vision a reality. There are different kind of angles and different takes in design and architecture among these solutions. But as long as we can deliver the end experience, I don't think it matters too much what happens underneath. Then they can be optimized in various ways. So we're pretty excited about based rollups in general. That does not mean a vote of confidence in that it will definitely be a thing and it will be the vision that it needs to be. But we're here for the ride to see if it does, and we'll have learnings if it doesn't.
Do you think like Ethereum basically becomes this settlement ground? Not really too many people operating at the L1 level, but most of the block space for Ethereum gets eaten up by L2s submitting their transactions?
No, because gas is cheap these days. I mean, if you look at a gas, like I'm looking at the block native gas estimator right now, it's 17 Gwei to get a transaction in, which is like not that expensive. So
Right.
if I have some funds on Ethereum, particularly if I have ETH for purposes of Ethereum, like I'm gonna stake it, I'm gonna do something with it. I'm just not gonna go to another chain to do that. So I think we will continue seeing ETH only use cases, but a lot of this retail activity around, maybe it's speculative, maybe it's minting the latest NFT or whatever it is. A lot of that could go trickle to the rollups, in my opinion. But I don't believe that ETH L1 activity will be confined to I don't think ETH is going to become this B2B chain, basically, right?
Okay.
I think consumers will continue to use it for their own purposes. Particularly, I mean, there's a lot of whales out there that have a bunch of ETH and stuff. I don't see them, using some risky bridge to, put that on somewhere else. Maybe some of them will, but yeah, some portion will continue to live and thrive on Ethereum.
Okay. Interesting. And so what I'm also curious, like what was your impression of Vitalik's presentations out there? Just kind of as we wrap up, coming full circle back to
I was at his sequencing day presentation, which was right after mine, actually. I wish he was there for mine, so he saw it. But essentially, he talks about the guarantee that you talk about, which is kind of a little softer than this finality level of security. But he also talked against leveraging the proposer monopoly to do this, right? So some of the pre-confirmation visions out there leverage the proposer monopoly to say, hey, this proposer, because he has the ultimate power, will then decide which transactions are pre-confirmed and which are not. Now, there's many problems with this. The proposer is not in the best position to do this because there's a lot of private order flow that they can't see to make this decision. But the concept of it kind of strengthening the proposer monopoly and moving the needle further along this fat proposer thesis is particularly what Vitalik spoke against a little bit. So, and that's where kind of our design with MEV Commit shines. Not to kind of show MEV Commit more here, but it's really that it does not rely on the proposer monopoly. It is compatible with multiple concurrent proposers. As long as they can issue commitments and use this network, it will continue to work. So, Vitalik then goes on to suggest, well, what if there was like a subset of let's say 2 or 3 validators who could attest to this transaction? And if you get all 3, then your transaction would be pre-confirmed. Well, that's practically what MEV Commit mimics, right? You have, few block builders that are highly sophisticated. And if you get a commitment from all of them, your transaction is practically on chain, right? So, I think he'll find out about this design soon, especially as it goes to mainnet. And in my opinion, he'll be delighted to see the route that we've taken with the design choices that we've taken. And we've engaged with a lot of researchers in the ecosystem since we've been doing this for a while. And there have been people who said, "Hey, yeah, this is actually a good design." And there have been people who have said, "Hey, I'm not really sure. This is kind of like probabilistic and whatnot." And then 3 to 4 months later, they've come back and said, "Hey, you know what? I've really gone down this path, and this seems to be a better design. The design choices you guys have made seem to be along this path." So I think the knowledge gap is closing when it comes to this, and a lot of people are starting to see that there really is a best path forward to give execution pre-confirmations, and that almost has to come from block builders or people who have deep knowledge of the current state of the transaction landscape.
Very cool. Where can people find out more about MEV Commit and dig into the research and give you some feedback?
Yeah, mir/preconf.eth is a good one. So all of our research is on mir.xyz/preconf.eth. So you can read a lot about it there. docs.primev.xyz. We have a brilliant AI in there, so you can just talk to the AI and don't have to go through every single page of the docs. It'll point you in the right direction for your specific question. It might be the most knowledgeable anything about pre-confirmations. It's a little bit better than humans in some ways, and in some ways not. Following us on Twitter is a good one. We put out research fairly often. That's I would say the main sources. If you're code savvy, go on GitHub. Everything is open source. Everything's built in the open. GitHub/Primev will give you all of the MEV commit related code and software as well. These are some of the top places that you can learn more.
Awesome. Thanks so much for coming on, man. It was a pleasure chatting MEV Commit and Pre-Confs. Maybe we'll do another one again soon on based rollups and base sequencing.
Yeah, would be happy to. And I think once we have mainnet results too, similar to the ones that we have on testnet today, things can get really interesting, and that could be a good time to continue the talk.
When mainnet?
Sooner than you think.
Sooner than you think. That's a good answer. Cool, man.